Yeah, the session will also be recorded. So thanks for joining us today to the meetup, a Swiss meetup this evening. I think with an absolutely marvelous, interesting topic. So I'm really looking forward to it. We will talk about Flair, state-of-the-art natural language processing, and we have Akbik here, who's actually leading us through the evening. Yaroslav is asking, how many are we now? A lot, I would say. We have already started with 34 people, so coming in. A few rules for this evening. Since we are, of course, not physically near to each other, but at least virtually, feel free to ask questions at any time of a presentation. If you look at the menu from Zoom, you will find some kind of, there's a chat functionality, so you can chat with me. And there's also a question and answer section. If you click on Q&A, you will actually have the chance to ask questions. So during the presentation, I will have a look at the questions coming in. So Ellen can focus more on presenting the stuff and showing the demos and so on. And I will have a look at what kind of questions you have, and I will always check that we get the questions answered as well. So feel free, ask the questions, don't feel scared or something like that. We are just all people, all humans, so no worries about the bad questions. There are no bad questions. They're just questions we do not ask, which is the worst thing. So happy to have you here in the team. Ellen, thanks for joining us.
Thanks for having me. Thank you.
Just for all those people who haven't heard about you yet, I have been following actually your posts when you were working at Zalando. What was your job there?
I was, at the end, I was research lead for natural language processing. So I was organizing the NLP research we were doing at Zalando.
I thought you're just selling shoes. So what does NLP mean with shoes?
We also do some NLP. I actually have some example in my slide, what kind of NLP we do, or we did at Zalando still does, but now without me at, but yes, NLP is everywhere, and text data is everywhere. So the big companies, even if they sell shoes, they do some NLP.
Oh, there's hope. There's a hope out there. So your background is, are you a researcher, academic, or what are you? Basically, are you a data scientist?
Yeah, so I've kind of moved back and forth between industry and academia. So after I finished the master's, I went to a startup here in Berlin as a research engineer for 1 year. Then I went back to university. I did the PhD there in computer science and NLP. And then after the university, I actually went back to industrial research for many years. And now I'm back at university. So it's kind of been going backwards and forwards between the two. So I feel I'm somewhere in the middle between the two, academic and industrial researcher.
So it sounds like a never-ending love too.
Yeah.
That's interesting. What actually made you so passionate about natural language processing? What is it?
Yeah, I guess for me, it's actually human language itself. So it was, for me, it's kind of a little bit of a hobby to learn languages. So when I was studying computer science, I actually didn't know in the bachelor in what direction I wanted to take it. But then I discovered that I really liked learning languages. So it started with French when I was doing an Erasmus year in France. And then I realized that it's actually possible to bring those two things together. So interest in human language and computer science. And that was just a natural match for me.
Sounds, what a pity. That's good. I mean, it's always the best thing if you can follow your passion. That's a nice thing. Looking at the work you did, so Flair, why did you come up with Flair? What is the history of that?
So I do cover it a bit on my slides, but yeah, so actually I'm going to refer to the slides because it's the opening few slides. So
you want to increase the tension with me?
Yes.
Okay, good. I have to deal with it. I have to live with it. Looking at are you going to answer questions like what's the role of Flair in the NLP world? So what is different to other libraries? Will that be covered a little bit?
Yeah, so I think one big difference is that we support a lot of different embeddings and standard architectures.
Yeah.
So we actually support a lot of like current embeddings out of the box, like BERT embeddings and Flair embeddings and Elmo embeddings, and different types of word embeddings that have been proposed over the last many years. And it's possible to essentially mix and match these embeddings in standard neural architectures that you use for many NLP tasks. So that makes it possible for you to actually train state-of-the-art models for many tasks. We're fairly confident that if you follow the guidelines of Flair, we have tutorials, and you train your own models using these recommendations, that your models will be extremely good, extremely powerful, because we basically use in many cases the latest research that is available to the research community, and that's all made usable through Flair.
Awesome.
So, yeah.
Did Flair start at Zalando, or did it already, or was it born before that?
It was born at Zalando. So it was when I was there, it kind of accompanied one of our first papers that we did.
Yes.
So we developed this new type of embedding. I'm going to talk about it. And we were actually super confident about this embedding. We were sure this embedding is going to be very useful to a lot of people. And so we wanted to make sure that people can actually use it. And so we developed this framework basically to deliver our research to other people so that they can use it within the company, but also research groups outside of the company.
Interesting. So it was just born in the corporate world, but it's actually not proprietary stuff. It's open source, right?
Yes, it's fully open source. It's fully free. Nobody's making any money.
Yeah, that's cool. I mean, that's perfect for us here. So we can actually work with it. That's fine. So open source, but open source is for you also a very specific story. In our first talk, when we first discussed, you told me that you're also passionate about open source. Why do you think open source is so important?
So my own experience with open source has been super positive. So I think it's actually really cool to have a community of people that work together on these projects. And especially in research, I find that this is really helpful to making sure that people can reproduce other people's research and that they can use other people's research. So the open source community really has been just tremendous. I mean, Flair, when we open sourced it, was basically a research prototype, basically just something that we open sourced together with a research paper. And because of all the interest from the open source community, actually this what was only a prototype really has grown into this framework that now so many people use. So this was really the open source community doing this. So this is the reason why I'm really passionate about it, because I've seen it work so well. Yeah.
That's cool. So basically all of the participants today could also join the team to develop it further, right?
Yes, please. Everybody join.
So welcome again for everyone who is just joining. Happy to have you here in the meetup today, the virtual meetup. We have Ellen here presenting Flair. You might tell a bit about the name, why you came up with that name as well. But let me just send one question to all of you. Please answer the poll. It's a quick one. It's very, very fast. Tell us a little bit more about your level of knowledge you have in natural language processing, so that it might be easier for us, for Ellen, or especially to understand how we can address your expertise. No one will get frustrated or left behind. So that would be awesome. Thanks already for, I see the answers coming in. That's cool. So yeah, we have a good mix between novice and advanced. That's what I'm saying, seeing already. That's interesting. Some first time timers as well. Happy to welcome you to NLP as well. It's cool stuff, yes. So I love it as well. And I'm working with NLP. That's also kind of dedication on our side here. Yeah, still some answers coming in. Let's wait until it's completed. Again, welcome Ellen to the talk this evening. There will be another talk next week. I'll just announce it also for you guys. It will be more about bias, bias in machine learning. I found that quite interesting, especially people of color have huge problems from the things I just recognized from people talking to me. And we will someone expert in that area from Google next week joining us to talk about how algorithms can be more fair if you build it in the structure of how you build models. I think that's also cool stuff. So I think most have replied. Let's just close the poll for a second. Yes, so Ellen, I don't know if I can publish it. I'm not sure if you can see it.
Yes.
Fantastic. So as you can see, most people are just novice. So that's cool. So we try to get you in the board, help you to understand what's happening here, maybe answer some background information why Flair might fit into the NLP world at all. We have a lot of people who have advanced knowledge, which is also cool. I know that especially in Switzerland, a lot of people do NLP. If you look, if you would do a survey, I would say most are advanced in NLP, and there's less knowledge about computer vision stuff, for example. So this is still NLP very focused. Good. Thanks again for just replying to my question. That's awesome. It helps us a little bit better to focus. That's cool. Now, Ellen, I would not like to stop you from talking anymore. So it was maybe just our first warm-up here. That's fine. And I would like to hand over the talk to you and show us what you want to show about Flair, please.
Okay, great. So I'm going to share my screen.
And for all other people, just remember that you can ask questions. So there's a Q&A section in the menu. So just send me your questions. I will pass it on to Ellen. Chat only if you have general things to say, but use Q&A, please. Thanks. Ellen?
Yes, please. So ask questions, because I'm always happy to get some resonance and not speak for 1 hour without interruption. That's the worst. So please do ask questions. So Steffen, can you see my screen?
Yeah, I can see the presentation.
Perfect.
It's fine.
Okay, yes. So the title of the talk is the Flair Framework for Text Analytics and NLP Research. Maybe a quick introduction, even though we've kind of already had it. So I joined the Humboldt-Universität at the beginning of this year as professor of machine learning. Before that, I spent a lot of time in industrial research. So I spent a couple of years at IBM Research in California, and then the last 3 years at Zalando Research here in Berlin. So I'm sitting in Berlin. The focus of my group is natural language processing with various deep learning techniques. And a big focus also of today's talk is the open source NLP framework that we are developing, which has the name Flair. So this talk is on the one hand about Flair, but at the same time, I also want to talk a little bit about the research that we're doing in natural language processing. Okay, so the outline of the talk is we're going to talk about the framework first. We're going to some motivation of why we created this framework, and we're going to look at different NLP tasks. And so for each task, I'm going to show you guys a live demo, because I really like demos. And also, as we look at these NLP tasks, I'm going to talk about some of the research that we're doing with regards to these tasks. Then another thing that I want to give you guys a sneak preview, so you are the first. We have a big biomedical release coming up where we're adding biomedical capabilities to Flair. And I'm going to show you the first live demo. So it's going to come soon and you're going to see it first.
Ellen, that should have been announced earlier. I have no drums here. So yeah, there's the tush. Thanks for that. Yeah, I think it's pretty interesting that you have the demonstration of it with you. That's awesome, because it's much more, it's much greater to see it in action. That's pretty helpful.
Yes, so I'm hoping maybe there are some biomedical people in the audience. So maybe
Let's see.
You guys.
At least we have Tobias, who said he's an advanced practitioner from Flair. So and he has used Flair before, so cool.
Cool. So this is the first part of the talk, and this will be like 90% of the talk. But I also want to talk a little bit about some research that we're currently doing in the area of never-ending learning. So here we're researching neural models that essentially, as the name says, never stop learning even during prediction. So if there's time, I'll talk about this as well. Okay, but to begin with the framework. So this all started in 2018. We're doing research at Zalando, and our research was in the area of neural language modeling and named entity recognition. So in named entity recognition, that's the task. We go through text and we're trying to identify groups of words in this text that belong to certain semantic categories. And since, as in the beginning it was already mentioned, Zalando is a fashion company, what we were interested in was fashion entities. So fashion entity, if you look at the lower sentence, I don't know if you can see my mouse, but Alexander McQueen, for instance, that would be a brand name, or identifying like looks and seasons and colors and dress items and this kind of stuff, right? So this is what we wanted to develop. And when we started the project, we found that we were actually kind of unhappy with the reproducibility of research papers that we were reading. So we were reading all the research papers on named entity recognition, and we thought it was really hard to reproduce these great numbers that they were reporting. And we had several categories of problems. So one category was that some papers only report the results. So they show you very nice numbers, but they don't actually open source the code that they use to produce these numbers. Some papers write that they might release code in the future, but they actually never do. So this is another thing that can sometimes happen. Another thing that's actually very common, and this happens all the time, is that code is in fact released, but it's basically impossible to get running. So you invest days and days and try to get this code running, and it's just not possible. So I actually just had a case a few weeks ago. I'm not naming names, but it was a research paper. They had like a totally impossible combination of like a really old TensorFlow version, Python 2, CUDA 9, and it was just completely difficult to read code. And I wasted like 2 days trying to get it running. So this happens all the time. And this is what we call fake reproducibility, because the authors can always say, oh yeah, we released the code, you can use it. But we find it's actually really hard to get running.
So there's no standard for that, but it is a requirement to deliver code with papers?
It's not a requirement, but it's generally good to do it because it helps you get your paper accepted. Right? Yeah. And then finally, there's the case script produces number, where the code is actually easy to get running, but then it does like some sort of a script and it runs for several hours and then out comes a number, but you have no idea what actually happened on the way. So basically, these were all kinds of different cases that we found, and that made it really hard to take like the best 10 papers, put them next to each other, and say, okay, we're going to compare all these approaches and reproduce these numbers. So we thought, okay, so how should we do it then? So if we really want reproducibility, how would that look like? And so this is really not rocket science. So this is super obvious stuff, actually. So for instance, we would like to have really quick setup. So basically the code should contain everything that is necessary. So not just a framework, but also all the data sets that are necessary to reproduce the results. All the models, if we use word embeddings from somewhere else, we shouldn't be chasing around the internet to find them. Everything should be there. It should be modular, which is obvious, right? So we want to look at the code and be able to understand which component is doing what. And also we want to be able to switch out components, right? So we use a lot of embeddings in natural language processing. And maybe if a paper releases an approach that uses glove embeddings, it should be very easy for us to exchange this embedding with a different embedding, like BERT embeddings, right? It should be applicable to new data sets, meaning that there should be no data set specific assumptions in there. Rather, this approach should just be usable for new data, for new tasks, right? And finally, this kind of follows from all the rest. It should be easy to build on top, right? And so as I said, this is not rocket science. So if you look at the slide, if you look at the adjectives on the slide, these guys, you're going to find that we use the words quick and easy a lot. Okay, so basically what we really wanted is research that is easy to reproduce. And since we were in industry, research that is easy to apply to stuff, right? And so this motivated the development of the Flair framework. So the tagline of Flair is a very simple framework for state-of-the-art NLP. And the tagline kind of contains the two things that are most important to us. The first one is that it is easy to use. So this is something that we are working hard towards to make it as easy as possible to set up and use. But at the same time, even though it's easy to use, we want it to be state-of-the-art in the sense that it uses the latest research that is published in NLP, right? So the framework is built on PyTorch, and it's actually, so of the deep learning framework PyTorch, and it's actually an official part of the PyTorch ecosystem. And as said in the beginning, it's very much open source and free. So with a very nice and active open source community that has really made this framework into what it is, with a lot of contributions I'll talk about later as well. And we are currently at version 0.51, and I'm going to tease 0.6 in this talk today. Yeah.
Alan, since we have a lot of people who are just new to NLP, what's PyTorch?
Yes, so PyTorch is one of the two big deep learning frameworks. So if you want to use deep learning, basically you're going to use either TensorFlow or PyTorch, which are the big two frameworks to do it. Yes. And so now what I would like to do with you guys is we're going to walk through a bunch of NLP tasks, and I'm going to show you how Flair does it. I'm going to show you some demos, right? So one of the biggest NLP tasks, or one of the most classic NLP tasks, is text classification. So in text classification, what you do is you have a piece of text, and you want to automatically detect whether it belongs to one of the categories that you have defined, right? And so a very standard example is sentiment analysis. So you have a piece of text like, I really like this movie because, and you typically define two labels, one is positive and one is negative. And you want the machine to be able to predict whether this text is positive sentiment or negative sentiment, right? So if somebody writes, I really like this movie, the machine should say this text is positive sentiment. If somebody writes, I really hated this movie, it should be negative sentiment, okay? And so this is implemented in Flair, and I'm going to show you a demo of sentiment analysis in action. So let's see. No, okay.
Yes, I can see.
You can see it? Okay. So I'm going to type in some sentences and we're going to see what the model gives us. So I'm going to start very optimistically and say, this talk is interesting. So I'm going to click on this button and we're going to get a sentiment prediction for this text. Yeah. So we have two models. One is based on transformers. The other one is based on recurrent neural networks. And in this case, it's a very easy example. Both models are saying that's positive sentiment. Yeah? So if instead somebody writes, or I write, this talk is not interesting, I'm going to get my prediction. And now we have two predictions that in both cases are negative. Right? So this is an easy example. Let's make it a bit more difficult. So let's say this talk is as interesting as watching paint dry. So if somebody writes, this talk is as interesting as watching paint dry, this is an expression in English, which is generally not a good thing. So let's see what the model does. And what the model does, it's very uncertain here, you can see this, yeah? But in both cases, the model is tending towards negative, right? Because it is in fact a bad thing, and it's very likely that we have a huge training corpus that people have used this expression in the training corpus. So the model can learn this kind of stuff.
So phrases are known to the model? Such phrases like watching paint dry?
Potentially, if it's in the training data, yes. So we used a huge training data set from Amazon product reviews and some other data sets. And basically, so to supervise this, you know, on Amazon, you can write a product review and then you can give stars. You can give 0 star, I don't know if you can give 0 stars, but you can give 1 star, or you can give all the way up to 5 stars and you write a text. And so basically we use the signal as supervision. So if all the texts that have 5 stars, we use them as positive examples. All the texts that don't have so many stars, we use them as negative examples. And since the data set is gigantic, it's likely that phrases like watching paint dry are already in there, right? Mm-hmm. So if I write now is as interesting as watching a baseball game, okay? This talk is as interesting as watching a baseball game. Now I get another prediction. And now the prediction is flipped again to positive. So our model seems to believe that watching a baseball game is a good thing. That's interesting. I don't know. So this is, yes, so this is sentiment classification action with two different models.
This again shows that context matters, right? If you're a baseball fan, that's beautiful, fine. And you know, that's positive. If not,
Very debatable. So me personally, I'm not a huge fan. So
okay.
I say it's as interesting as watching a baseball game. I would probably say it's
okay.
more negative, but you know, that's
not my world. Okay.
Like it, so. Okay, so text classification, but this of course is a super simple example. So this only uses 2 classes, positive and negative. So text classification is so powerful because you can define classes for anything, right? So another usage, for instance, is hate speech detection on the web. So there's now a German example, but if somebody writes "Du bist doch ein," some horrible thing, you know, that people like to write on the web, you would train a machine to detect.
What you usually don't have to say it. So it's like,
Yes.
camera. So don't worry.
Yes. Basically, we train the machine to detect whether, first of all, the language is offensive or not. So is it hate speech, yes or no? Or is it offensive language or not? And if it is offensive language, then which type of offensive language is it? Right, so there's different types of offense. And one of them is insult, what you see here, if there's like a personal insult. And so now you're training the machine essentially to predict one of not only two classes, but one of many classes, right? Because there's many different types of offense. And so this is actually, as you can see, text classification is super powerful. So you use it in tons and tons of applications. So for instance, chatbots use it a lot to detect intents. So if you tell your Alexa, give me the weather or something like this, right? Then basically they have like hundreds of intents that people might say. And one would be intent, give weather. And then you do this classification. There's a lot of like work in political sciences that I think is super interesting in terms of hate speech detection, detecting fake news, detecting political bias. And all of this can be modeled as a text classification problem. And in fact, we have a project that is in preparation with political scientists here in Berlin, where we want to analyze the impact of communication on social cohesion. So political communication, but also communication of people on the web, how they discuss politics with each other, like how this affects the cohesion, like the way, the social cohesion fabric of a country, right?
Yeah.
So
one thing, since we know that a few people don't know, or it's the first time we started with NLP. So sentiment analysis and hate speech detection are typical tasks you can do with NLP, right?
yes.
Ellen, sorry, because I interrupted you already. I have 4 questions here, and I would not like to leave them just without addressing it. So Yaroslav is asking what languages is Flair working with?
So it's now supporting to different degrees 300 languages. So, but it really depends on which task, because there are many different tasks. I'm going to cover, and it really depends on which task, but generally the community has really scaled this up to many different languages. So there's no principal limitation that you cannot use it on your language. So I even have a demo later of some multilingual stuff. But yeah, it scales across languages, I think, pretty well.
So that's just also the next question here from someone anonymous who's asking, is it a multilingual model being used, or is it language-specific Flair?
Both. So we have language-specific models for many individual languages, but we also have multilingual languages. We have language models. So one language model is trained over text in 300 languages. So this covers, I think, a lot of languages.
Yeah, sounds like that. Is there a relationship between Flair and NLTK?
That's a good question. I actually, to be fully honest, I haven't used NLTK in a really, really long time. So I don't know if I can answer that question. So maybe somebody in the community can answer it if somebody has used it. It's kind of the downside. If you spend so much time developing your own framework, you don't have so much time to look at all the other frameworks. So sometimes these comparison questions are a bit difficult.
Yeah, comparison is always a little bit difficult. I know that a lot of people just left NLTK to Spacey. So yes, maybe we can answer that in the future and just leave it open. Can you, what are the pros and cons of using language-specific versus multilingual models?
So it's actually, so the pros of using language-specific models is that they will always, language and domain-specific models will always give you the best quality for your language. So if you really know you only have one language and you want to maximize your accuracy, you're going to want to have a model that's specific to your language and your domain. But I'm going to show a demo in this later, but a multilingual model has a lot of convenience. So for example, I was working at Zalando, right? So Zalando operates in all of Europe or in most of Europe. And so customers might use any language, any European language, right? And so it's very convenient to have one model that can deal with all of the languages at the same time, right? Otherwise you would, let's say we have 12 languages, you would have to maintain 12 separate models. You would always have to do a language detection to see which language is the customer writing in, then select the appropriate model. But if you have one model that does everything, then it's much more convenient, right?
Interesting. I just put Tobias on the panel for a second because he just wanted to know, or I had a question as well. He said, how does Flair compare on a high level to Hugging Face transformers?
I think that's a bit easier. So on a high level, we use transformers. So for the transformer model that I just showed for the sentiment analysis, we use the embeddings that are supplied by transformers. So it's however just one of multiple embeddings that we use. So we also have many different types of embeddings that come from our own research or from other research groups. So basically what Flair allows you to do is actually combine things like transformers, classic word embeddings, language model embeddings, like this kind of stuff.
Interesting. And Victor, because you just have it here in the list of bullet points with chatbots, spam filtering, and so you have chatbots mentioned as well. And Victor just wanted to ask if you have any kind of detail of application of Flair for chatbots, or do you have an example later on?
I don't have an example here. So we did intent classification, for instance, at Zalando for like a chatbot that they were developing. But it's basically just like text classification. So if a customer writes something, so I forgot unfortunately the details, but if there's like certain classes of wishes, like, I don't know, I would like to return my product or something like this, right? Or I want to know when my product is being delivered, something like this. And basically, so the customer would type in a piece of text, you would predefine just a number of intents, and that could be a lot of intents, could be hundreds of intents. And then your text classification is running over what the customer typed in, and you're trying to determine the intent. And that's basically it. So it's just normal text classification used in a chatbot.
Mm-hmm. Okay. And the last question, you can move on with your slide here, from Louis, who just wanted to know if you're going to talk about fine-tuning support with Flair as well.
Yes, so we have fine-tuning support. It's not in the slides, but a lot of stuff can be fine-tuned now. All the transformers can be fine-tuned. The language model embeddings can also be fine-tuned. And in fact, the sentiment model that I showed, the transformer one, is based on fine-tuning. We ran actually a lot of different comparisons between fine-tuning and training. And we found that each has their own application. So for text classification, you absolutely want to fine-tune a transformer. For sequence labeling, you don't. So, I mean, it's not in the slides, but there's different applications for both things.
Mm-hmm. Thanks. Okay. You're fine.
All right. Okay, so this is text classification. Let's move on to another one that we really like. This one is called sequence labeling. So here we treat text as a sequence of words that we want to label. And I showed in the beginning named entity recognition. So in this task, we're looking at all the names in the text, and we want to identify the semantic class to which these names belong, like identifying this is a person, this is a location, this is an organization, this kind of stuff. Another application of this is part of speech tagging. So in part of speech tagging, what we want to do is we want to identify the syntactic type of each word in a text. So we want to identify the verbs, the nouns, and the adjectives, and so on. All right, so this is something that was the original task actually of Flair. So I want to show you some demos of this.
By the way, if you find out names like Charles Michael and Tony Hall, can you already recognize them as politicians?
So we don't have a model for this. So this is a training data situation, but this is something that we would like to do. So identifying fine-grained entities is something that's on our list.
Oh, cool. Okay.
So I'm going to show you some simple examples. This is my was born in Washington. That's not true, but I'm using this just to show you some things. So the sentence is George Washington was born in Washington, and we're going to do entity detection, right? And so entity detection now tells us George Washington is a person and Washington is a location. And the reason why I'm using this example is because I want to show you what happens if we type in Washington was born in Washington. So if we type in this and we get our prediction, we now find that the first Washington is typed as a person and the second Washington is typed as a location, right? So what we expect our models to be able to do is to identify, even for ambiguous verbs, so words that have different meanings, to identify what they mean, right? So this is the entity level, and to give you maybe a different level, part of speech.
I mean, that's pretty interesting. How does that work? How can you distinguish between the name of a location and a person name?
It basically uses surrounding features as well. So it doesn't just look at the words, but it also looks at like the whole sentence and sees that if somebody was born somewhere, or if you were born, yeah. So basically you can use these patterns to identify things, right? But yeah, okay, so now we have a different level of annotation. This is part of speech tagging. And we, for example, identify that born is a verb and that Washington in both cases are proper nouns and was is an auxiliary verb, right? So these are two different levels of annotation. Yes, going back to the talk. Yeah, so this is again, super important task in NLP. So we use it on so many different things. To give the Amazon Alexa example again. So if you tell your Alexa, please play me a song by Bob Marley, right? Then you have the intent classification. The intent will tell you that's identifying the whole text. This text means play a song. But Bob Marley, if you say play me a song by Bob Marley, you're using entity recognition to go into the text and identify which words are like a song title or like a name, right? And so this kind of stuff is what named entity recognition is used for. And there's a lot of different domains that use it. Again, biomedical, law, social sciences, there's many reasons why you would want to do that. Even like there's a lot of anonymization use cases where you have data and you want to anonymize all the names, all the addresses, then you can use named entity recognition, run it over the data and blacken out the names or replace them with pseudonyms, right?
Well, there's one understanding question like, does the parts of speech tagging, which is actually happening here, does the parts of speech tagging use pre-tagged pools of words?
So the part of speech tagging is supervised with training data,
yeah.
But there is no list. I don't know if that's the question, but there is no explicit list telling us this word is an adjective or a noun. So this comes implicitly out of the word embeddings.
Okay.
Yeah, but maybe to give some more details now, so I showed some demos, but maybe to give some more details on how the sequence labeling works. So basically one of the reasons why it works well, so the sequence labeling works, we think very, very well in Flair, is that we use something we call Flair embeddings. So this is confusing. The framework is called Flair, but the word embeddings that we have are also called Flair embeddings. So that's on us. But essentially what we do is we train a character level language model. So if you see a sentence like George Washington was born, blah, 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 what happens is that we analyze the sentence at the character level, meaning that each individual letter or each individual number becomes its own thing. So we chop it into characters and we stick it through a pre-trained character level language model, right? And so I'll talk about this language model a bit more on the next slide. But what this language model essentially does is, for us on a high level, it contains knowledge. It contains like so you could call it a general linguistic world knowledge model. So basically this character language model can see this text and it knows things about this text. Let's just leave it at that, and I'll say more on the next slide. And from this character level language model, what we now do is we extract word embeddings for each word in the sentence. And we do this by looking at the first and the last character of each word and concatenating them. So there's a forward character level language model and a backward model. And from the forward language model, we take the last state, from the backward, the first state. There's reasons for this. We concatenate the internal hidden states, and that gives us a vector now for each word. So this vector is a vector representation that gives us information about previous knowledge that we have about each of these words, okay? And then what we do is we stick it into a sequence labeling model. So this is a standard sequence labeling model that goes through the text and looks at each word and tries to predict what it is. So what you see here in the image, you have George, that's labeled as the beginning of a person. Washington is labeled as the end of a person. But this is a model for a specific NLP task. So this model we train using data for this specific task. For example, for identifying names. And so as we train this model, this blue model, the model is kind of looking into this world knowledge model, and it can use the knowledge that we have in this model, right? And this is what makes it so powerful, because now we're training this model, but it can also use the world knowledge, yeah? So how does this world knowledge look like? So where is it coming from? So we basically use a language modeling objective. So if we want to pre-train, if we want to learn language about the world and knowledge about the world, the main idea in NLP has always been to take plain text, for which there's unlimited amounts of plain text available, and make a prediction problem out of it, right? So we can crawl the web and we can have 1 million websites, and then basically we make a prediction problem out of this text. And the prediction problem that we're looking at is we're training a language model to predict what the next character is going to be, given all the characters it has already seen. So basically, if we have a sentence like, I started the car, our language model should be able to predict what is a likely next character that's coming now, yeah? So what's the next one going to be? And now you have a lot of options, like the whole alphabet, but probably likely alternatives are a T or an R, okay? And we don't do this only one time, but we go through a huge corpus, and at each single character in this corpus, we're always training to predict the next character that's coming, okay?
Okay.
And this has a lot of advantages, because that means we now model language at the character level, meaning that we don't have assumptions in there, what is a word? We have a very small vocabulary. So vocabulary refers to like the atomic unit of language that we're looking at. And in previous works, the atomic unit at the time was whole words. But then of course you have hundreds of thousands of words in a language. Whereas if you look only at characters, you only have like a few hundred letters of the alphabet, numbers, some special characters, right? There's not so much, the vocabulary is very small. And most importantly, we can learn subword features, meaning that we can learn things like, this is an ending, this is a prefix. So this actually makes it really nice. And so we train this task of predicting the next character over tons and tons of data. And then at some point we have a trained model. And this model has learned a lot of things about distributions of characters and language. And what we can do is now we can sample this trained model. For instance, we can give it a prefix, and we can ask, what is a likely continuation, according to what you have learned, what is a likely continuation of this prefix? And so a standard test is saying the meaning of life is, and having our language model complete the sentence. And so this is a model that we've trained a long time ago, but our model was saying the meaning of life is so complicated and it is a mere step forward. So these are different samplings, but also longer stuff, like it's a bit like a particular provocation, and it's entirely confined to the world of animals, but the world has to be profitable, okay? And so these are things that come out of the language model that we've trained. So the knowledge to generate these sentences is there, right?
If you say you predict the next character, it's actually starting in the example, if I started with CA, you start with I in the beginning, right? So each character is adding a probability towards the prediction of the last character you're actually looking for, right?
Yes, so you look at the entire sequence, yes. And so if you sample like the trained model, you will be sampling one character at a time. So you sample an S, then you sample an O. Basically you would continue the sentence, sampling one character at a time. And what is interesting, if you look at these sentences that were sampled, is that even though we never told this language model what a word is or what a sentence is, it is producing grammatically correct text. And the text it makes a little bit sense. It doesn't make so much sense, but it makes a little bit sense. And that means that this language model now has a lot of knowledge about certain structures in language, simply by having learned these distributions, right? And that's actually super powerful. So now that since our model can now use it, we get really good accuracies. And a property about this approach that is very nice is that our vocabulary is very, very small. So because you're only predicting the next letter, you have a vocabulary of maybe 200 letters, and that makes it computationally extremely attractive. So it's much faster than other approaches that were out at the time. So it makes it, even as a small university or a small group, you can easily use such models now, right? And so this has two big advantages. On the one hand, we showed, this is from our 2018 paper, that at the time we very dramatically outperformed all the other approaches that were out there. So we set new state-of-the-arts for English and German and for some other tasks as well. But the most important thing is, even beyond this accuracy, that it's actually very fast, or at least for this class of approaches, it's very, very usable. And so when we open sourced this framework, a lot of people started using these embeddings for different tasks and started reporting new state-of-the-art scores for other things that we didn't have in the paper, right? So this is something that's both very accurate and also very, very usable.
What explains the difference between English and German in this case?
So German is just more difficult. So at least in this data set, it's more difficult. So for named entity recognition, I think one of the main differences is that in English, only names are capitalized, whereas in German, we capitalize every proper noun. Even non-names, right, are capitalized in German. So that's one difference. And German is also a bit more morphologically complex. So I think there's just some reasons why German is more difficult for this kind of thing.
Since you have been working in such an international company like Zalando, and we see now English and German, and I know from previous meetups, we sometimes had the question, of course, we always have English focused, right? And if you have other languages like Italian or French or Spanish or whatever, have you done a comparison for that as well, or is it just a focus on German and English?
So we have done, I have one more with Dutch.
Oh, cool. Okay.
So, in the company in Zalando, we actually used a lot of different languages. So we had, I think, 12 or 13 languages, like all the main European languages. And I think one of the papers also presents, I don't have it here, but one of the papers also presents numbers for 12 different languages. Mm-hmm. So we have worked outside of these languages, but in Zalando, it was actually very clear that German was always the first language that we worked on, because that's where most of the customers, or that's the language of most of the customers. And English, strangely, was actually one of the most rare languages at Zalando. So it's English, French, Italian, Polish, Dutch, which are big languages, whereas English wasn't a big language. So it's just,
that might be also interesting for the community, because we have a diverse community as well. For anyone who speaks just another language which has not been covered, that's your opportunity. Now do a test, please. Sebastian also had a question I actually had also in mind. Regarding to the previous slide, but actually leading to this one here. So predicting a character, actually you probably take into account as per sentence, right? So you need a beginning and you need an end at some point. It would be not a paragraph, a whole article or so. So I think you probably have a sentence as delimiter for everything, right?
So we've tried both. So it's not like it is in transformers where you have like these special symbols. So we've tried using delimiters and not using them. Actually, the difference was not very big. So we have approaches where we basically just take a text and with no pre-processing whatsoever, even documents, right? New lines, because a new line is also a character, right? Mm-hmm. So, and then just stick it to the language model. So that's very doable. So we never, for instance, introduce special characters for sentence beginning or sentence end, but they are implicitly there because in many cases, a new line means that a new sentence starts afterwards. Or like a new line will also indicate that a sentence ends here. So it's kind of there, but it's not explicitly there.
Okay, thanks.
Okay. Okay, so now we go to multilinguality. So there's another big advantage. So next to the runtime, a big advantage of going to the character level is that it makes it actually really easy to go multilingual. So, you know, in classic NLP, languages tend to be language specific. So you might have an English named anti-recognition model and a German model. And like we discussed earlier, you might have separate models for each language. What we, however, found that it's actually very doable to train one model over all the languages at the same time. And so, and this is especially possible if you use a character level approach, because if your atomic unit of language is words, then even going from English to German, which are two super related languages, is not doable because German uses different words. But if you look at the alphabet, it's almost the same, okay? So basically you can create an alphabet of all the European languages, and it's not big. And then you can train one single language model using text in many different languages. So we ourselves trained language models for, like I said, a dozen languages, but somebody in the community actually did a lot of work and trained a language model for 300, so a single language model for 300 languages.
Wow.
And again, it's very doable because most languages have, not all of them, but most languages have an alphabet. In Europe, it's mostly a Latin alphabet, a little bit Cyrillic, right? The Greek alphabet, but your vocabulary size is not big, right? And if you do it this way, the language identification becomes implicit to the model. So I'm going to show you now an example of this. Let's say George was born in Washington. So here we have the sentence, and born is identified as a verb. What I'm going to do now, I'm going to say George wurde in Washington geboren. So now George wurde in Washington geboren, that's the same sentence just in English. Now I'm going to get a prediction for this sentences, and what I get is that my model is able to identify that both born and geboren are in fact verbs, right? And what's even more, we are not telling the model this is a German sentence and this is an English sentence. So we're not explicitly telling this the model is just figuring this out by itself, right? So to cover all the languages, George, Washington, George, Washington. Correct me if it's wrong. And we find that ne is also a verb, right? So in all three cases, we never tell this model what is what, but the model can still handle the languages, all the languages, okay? And so this makes it nice. So if you, like we had at Zalando, have a use case where people might just type in stuff in any language, then you don't have to do like build business logic around it. You just, I mean, you still have to build some business logic around it, but at least the machine learning model can handle everything in one model, right? So this is the multilingual stuff.
Regarding just that, and can you just come back for a second? So if there are typos in there, so Akin is asking here, does subword analysis and non-tokenization give an edge over other algorithms in typo detection? Is there already an implementation for this?
In what detection?
Typo.
A typo, yeah. So we don't have, so what we have is, for instance, let's corrupt this a little bit.
Okay, nightmare.
Okay. So generally these models should be, okay, so they should be okay with a lot of spelling errors in the sense that these character level models are robust in the sense that if you train with them, your downstream task will be more robust, or I think it's better to show this using NER. Yeah. So if I say George was born in something something, then even though we've made a mistake, it can still recognize what it is. And if we, I mean, at some point, of course, it all falls apart. But it's actually not too bad. So you can corrupt it to the degree that doesn't work anymore. Yeah. So okay, now we have a mistake. Yeah. So these models tend to be very robust to spelling errors, and that's a big advantage of character level models. People have asked about typo detection in Flair, and we don't have a model implemented ourselves, but we would very much invite the community if somebody's interested in doing this. I think it should be possible to use character level language modeling here. So if you're interested in doing it, we would very much appreciate a contribution, because in fact, people have asked about this. So it's not on our personal list to do this, but I think the community would very much appreciate it.
I think it got heard. Yeah, typo, Louis, text correction. Yeah, I think you're not asking, but Flair would correct typos, right? It would detect them, but not correct them.
Yes, so generally there's a big hope that character level language models should be able to do this, because character level language models make this prediction, and they can, so essentially in cases where the prediction, where the model is very surprised, so where the text that it is seeing is too far outside of the distribution that the model has learned, that could be an indication that there's a typo or like a grammar error, like this kind of stuff. So I'm pretty sure something could be built on top of language modeling for this.
Cool.
Man, we are not in good time, but I'm happy that we have so many questions. So
I didn't tell you about that before. Maybe for good reason, but thanks.
yes. No, but I'm happy. I mean, it's always good to have many questions. That makes it much more fun. Yes, so that brings us to biomedical text mining. So this is a collaboration with another group at HU, with the bioinformatics group, in particular with students Leon and Mario. And essentially, the idea was to give Flair biomedical text mining capabilities. And so what they did a project called HUNER, where they looked at different corpora with biomedical annotation. And in fact, there's a lot of corpora out there. They're different size, different annotation assumptions, very different formats, but they gathered all these corpora, they normalized them, put them into a single format, and that allowed us to train big models over all of the corpora at the same time. So kind of like we did with the multilingual stuff, now we're doing it over different biomedical annotated corpora. And we also trained specific Flair embeddings on the domain of bioinformatics. So there's a lot of biomedical research papers, and we trained embeddings specifically for this type of data. And so what this gave us is, so this is a paper that is coming soon. I'm pretty sure the numbers are final, but you never know, so it's not yet submitted. But we compared our method against other off-the-shelf tools, and we found that Flair, so it's called Flair, outperforms everything else by a pretty significant margin. So what you see here are different biomedical entities like chemicals, genes, species, diseases, and miscellaneous is different, like an ensemble of different publicly available tools. Yes, so we trained all these models over all these different corpora, and this is coming in Flair 6, but I'm going to give you guys a sneak preview. But for this, I actually need help because I'm absolutely not an expert in biomedical, so I can't just give you an example out of my head. But this is like a text from like a research article I just found online on COVID-19, right? So, and this is, this model is not yet optimized, so it's taking a bit of time. Or maybe it crashed. No.
Interesting thing is that a lot of researchers try to help to make sense of academic paper and the COVID-19 research to help researchers to find their way through the waste material base we had.
Exactly. So what they want to do, for instance, they want to link, and so this is an example, diseases and genes, right? Basically, you go through all this biomedical literature and then you detect genes, or you detect side effects, or you detect whatever like things that people like biomedical people care about. And then you can find correlations in the data, right? So like I said, I just randomly copied this. So this is, there's many different entity types that are going to be supported in Flair, and it's going to be a lot faster than the demo that you are seeing now because it's not yet optimized at this point. But at the end, it will be as fast as all the rest. Another thing that is just finished today, training, so I'm going to show it to you anyway, is the scoping model. So this is also in the biomedical domain. And here, what you are trying to find out is which part of a research paper is an assumption. And again, this is not optimized, so it would be much faster. No, which part is speculation? And so in this particular text, it will say that this part of this article is labeled as speculation, like mortality might be due to hyperinflammation, right? And so these two things can of course be combined, right? On the one hand, you want to go through all your literature and find the genes, but at the same time, you want to understand like if certain correlations are only mentioned in certain scopes, like a speculation scope. There's another scope that's called negation. So if something is actually not influencing something, right, that's another scope. So this kind of thing, I guess people would want to do. And again, I'm hoping that there's some biomedical people in the audience because we actually just finished training this model. And I would be very curious to hear if that's actually useful for something. So
I think personally, I think it's quite interesting. We're currently investigating into disinformation. And so this might be a very helpful, but if you say it's speculative, quite interesting, but we can discuss that later on. That's cool. By the way, if you have that kind of models here, do you need to be actively using a model because you know what kind of text you have, or can we say articles could be just mixed between political articles, biomedical articles, and using all the models would actually find out what's the best thing to do in each case?
yes, so typically you want to train your models for like a certain domain. So it's always kind of like depends on the training data, though we do have certain models that were trained over mixed domain. So it always depends on if you have the training data available. The biomedical models in a sense might be seen as mixed domain because I said it's like 34 different corpora, and they are actually from, in a sense, different biomedical domains, right? So, in the paper, they actually show that it's, because we've trained over so many cross domains, it's more robust than other tools out there to mentions. But of course, if you want to have a model that goes for news articles and research papers, or maybe Twitter or something like this, then typically you want to train either your specific models or you want to have at least training data for each domain to make sure you have good accuracy.
Mm-hmm. Okay. Tobias had a question. Do Flair embeddings work well for clustering of short documents? Did you do experiments?
They actually don't work very well. So the problem with Flair embeddings, which is why we recommend using transformers for text classification, is that this character level nature is really good at identifying information on the word level. But if you want to have like information on what the whole sentence means, recurrent neural networks are currently not the way to go. Because what a recurrent neural network will do is it will go through the sentence either word by word or character by character, but essentially read it sequentially. So it's like a human might read one word after another and always build its understanding of what it's reading. And that seems logical because humans kind of do it this way, but the transformer approach is currently actually much superior because the transformer sees the whole sentence at the same time. Yeah? And if you want to classify the whole sentence, seeing the whole sentence at the same time is actually a really good thing. So, yes.
Thank you.
Okay. So I believe that was the last demo. But I do want to speak about some other NLP tasks very quickly that we also have in Flair, but they're kind of beta. One is text regression. So here, instead of predicting a category, we are predicting a continuous value. So instead of saying this is positive or negative, we're now predicting how positive is this text from 0 to 100%, or how negative is this text, right? And there we have support for some data sets from the Vasa challenge. And that's a data set that annotated, I think, 5 different emotions in text, like joy, anger, and fear. And you can use these models to identify how angry a person is that wrote this text. So we actually, it's beta. I mean, it's pretty much ready, but we haven't found so many use cases, or not so many people seem to be using it. So we're not putting so much focus on developing this. But maybe somebody has a use case, so that would be interesting to hear. Mm-hmm. Another thing that is bigger that we're working on is similarity learning. So this would actually deserve its own 10 slides. But basically what we're developing are methods to learn the similarity between 2 things. And the similarity, like the things that we want to compare, could be anything. So they could be multimodal, meaning that we want to identify the similarity between the text, dog catching a frisbee in the park, and the image of a dog catching a frisbee in the park. And so if our similarity learning works well, it would tell us that these 2 things are in fact similar, and 2 things that aren't similar are not similar. This actually we have some support in Flair, but it's super beta. There's a data set that we developed at Zalando that's in there as well, of fashion images and German language descriptions. But I think there's going to be a lot more submissions or contributions also coming from us and from partnering groups in this area, because the paradigm of similarity learning is actually super powerful. So the same paradigm can be used to solve a lot of different problems. Okay, so to maybe wrap up the Flair framework part, there's a lot of pre-trained models in Flair. This list is growing all the time: sentiment analysis, NER, part of speech tagging, models that I didn't show, and some models that I showed that are not on this list. And since we have a very good open source community, this list is constantly growing. If you want to set up Flair, it's very easy, we hope. All you have to do is type in pip install Flair, for instance, into a Colab notebook, and then everything will be set up on your machine to work, right? I want to show you a full code snippet of using sentiment analysis. So these lines of code is everything that you need. So first, what you're going to do is you're going to load a classifier. And the first time you execute this line on your machine, the sentiment model will be automatically downloaded to your machine. So, but only the first time you call it. So then you have it on your machine. So next time you call it, it doesn't download. And we have this system with all the models that we ship, meaning that you don't have to download it yourself. You don't have to do anything. The framework does it all in the background, right? Then you create a sentence object with the example that I used. The talk was interesting. You basically always have to wrap your text into like an object. And then all you have to do is call tagger.predict on the sentence. And then you print your labels, and then you have, in this case, either a positive or a negative label for the sentence. So we believe very easy to use, and all the models you can use like this. Every single model is just a few lines of code. So to kind of summarize Flair in a nutshell, what is it? For most users, it's an NLP library, meaning that you can apply our models to your text, just like I showed you. And we have a lot of included models to do it. So if you don't want to train your own models, there's a good chance that maybe we have some models that you want to use. You can also train your own models. So we have guidelines on how to do it. And we're actually very confident that if you follow the guidelines, you will get really good accuracy on your models. And a lot of people are using it. And because of this, it is now used in hundreds of projects. So we open sourced it 2 years ago. And we know it's used in just a lot of different projects. So a lot of companies are using it. A lot of research projects are using it. I forgot the number, but we have hundreds of dependent projects on GitHub. So it's actually used a lot. From the research point of view, it's an NLP experimentation framework. So in my group and other research groups are doing a lot of work on word embeddings, on text embeddings, because this is a really powerful way to make your NLP models better. And the nice thing about this framework is that you can just stick your new embeddings into it. So all the rest, like the architectures, the evaluation, the downstream neural models, all of this is already there. So you can just focus on developing your embeddings, you stick it in the framework, and then you can directly measure the impact on your downstream tasks.
Okay, cool. We have 2 questions, so that's by Luis. Can you hear me? And you can actually enable your audio if you like. You had a question.
Okay. I was asking about, okay. First, thank you for your presentation. And I was asking about if you have any experience with combining acoustic features with Flair or with text classification, sequence labeling, something like that.
It's super cool, but we haven't done it. So we are only now branching out kind of to new signals. So I have one student who is super motivated. So he wants to do translation, where audio signal goes in and then the end result will be also an audio signal. So, and that will go in audio, then to text, then to translation, and then back to audio. But really, we haven't really done anything. So here I'm happy to collaborate with people.
Good. I had some very little experience with text correction using acoustic features also, because, you know, many people say things that it seems to be correct, but when they write the sentence is wrong, but you know, the similarity of acoustic part is really, I mean, 2 words could be could have the same sound, but the people sometimes write in a wrong way, right? So you can use acoustic features to disambiguate or do something like that.
Yeah, I mean, that's very interesting. I mean, acoustic signal is also in many ways super interesting, like also for tone, right? If we say like sentiment, we had this example with the baseball game. So if you just read the text, you really don't know if it's positive or negative. But maybe if you hear the person who say, ugh, it's like watching a baseball game, then you know, okay, it's negative, right? So
yes.
Looks, Luis, like you should join the team here. Alejandro, thanks by the way for just asking. Thank you, Luis.
Thank you.
Thanks.
Alejandro, since you had a question as well, do you want to speak up?
Hear me?
Yes, perfect.
Okay. First from all, I am a big fan of the library. I've been using it a lot, actually in production right now. So that's what I was asking this question regarding GPU resources, because of if it would be possible to just to save some resources when we fine tune a sequence level model using the transformer classes. If we can use just a typical fine tuning, or we need to keep up with the LSTM CRF on top of the token embedding class that is used to train the sequence leveling model.
So in our experiments, so if you're asking about sequence labeling, so we ran actually a bunch of experiments trying to identify like what's the best combination of ways to do it. And generally, we find that if you want to use transformers and fine tuning, then you should not do, or it makes no difference. You don't need CRF and RNN, because the transformer is already so big, it's such a huge model. It can basically, the fine tuning should be enough. If you don't use fine-tuning, then it's better to use the LSTM-CRF architecture.
Yep.
And if you don't use fine-tuning, then we recommend using Roberta and doing an average over all layers. So Roberta with an all-layer average in our experiments was actually better than fine-tuning. So fine-tuning is kind of difficult, and I think a lot of people had difficulties reproducing the original BERT experiments for NER. So at least from what we found, it seems to be better to just use them as a feature-based approach.
Interesting.
Okay, thank you very much.
Thanks, Alejandro, for just asking. Tabitha, I also added you to the list of panelists here, so you can ask your question if you like as well. Tabitha, can you hear me? She's actually asking, when will the paper come out? And how can we find it?
All the papers are out. Or which one, the bioinformatics one or the...
It didn't specify, Tabitha, but if you just, so you can hear me, maybe you can ask what kind of paper you're looking for. Indeed, so I think I even put one paper in the meetup description. If not, we can, I'm not sure if do you have a link to papers on your presentation as well?
Hi, there was one you were talking about earlier. It was I can't remember what you called it, but you went through some of the results and you said you didn't think they were going to change, but who knows?
Yeah. So this one is, I hope, coming out soon. So essentially, so we are discussing in what order we're going to release everything, and we think we might release Flair first before we submit the paper. So then the reviewers can just check it out. So I think we're going to release Flair 6 in a few weeks, and then afterwards we're going to put the paper on archive, or maybe at the same time we put it on archive. So I would say probably a few weeks, but I said that before. So
thanks, Tabitha, for just asking. Victor, I put you here to speak up as well. Do you want to ask your question? It's a pretty quick one, by the way. Will the slides be available?
Sure.
Sure.
We can put them online.
Yeah, Ellen, I just thought it would be interesting to when I put the video up on YouTube, if it's fine for you, I would actually add a link to the PDF file of your presentation. Yes.
Yeah, I'll send it to you. Yeah.
Awesome. So I think that's good for all the people who try to look at the session at a later time as well. And we have everything in one place. I will also announce it for the meetup group so that everybody is aware where to find the information. And I think that was pretty awesome. Are we at the end of your presentation?
Basically, so we are at the final slide for this part. And given like how much time we've used on the other stuff, I think we maybe can relegate the research part to a future talk, because I think we're pretty much done, right? Or time-wise.
Awesome. Would you be willing just to do that another time? I think it was pretty interesting what you've been talking.
Yeah, so, absolutely. I'm happy to do it. Maybe wait a little bit of time, then we have more research and more new stuff to talk about.
Yeah.
But yeah, I'm happy to do it.
I mean, we keep in touch anyway. You can just tell me when you're ready with it, and we can go ahead with that. Alejandro just asking another question here. Currently, it's possible to seamlessly integrate custom word embeddings in the library. Would it be possible in the future to incorporate custom features like font size or font type as well?
That's a really cool idea. So I haven't had it on the roadmap. But it's a good idea. Yeah, I think we should develop things like this. So let's stay in contact. So maybe we can put it on there.
So Alejandro, you got the message. Stay in contact. Heike is asking how much data is needed to train a recognition model in a new language.
Yes, so we, the model that I showed you was trained over, I think, 20,000 annotated sentences. That's a lot, right? We have models also with, I think, 10,000 sentences or fewer. Generally, it's the way it always is in machine learning. So more data, better. But it's thanks to like these language model embeddings, you can even get okay accuracy with smaller data sets.
Heike, I just added you here as well. Did you have a specific language in mind?
Yeah, so I was just wondering, you mentioned 10 to 20K sentences. What would you say, like more data versus quality of labels? How would you prioritize between the two?
I would always prioritize quality of labels. So it's probably better to have really high quality data because you have good language models normally, right? Than having just a bunch of like noisy data.
Okay, thank you.
Thanks, Heike, for just asking. And we have a question from Himmet. You can ask the question now directly if you like. Just need to enable.
Can you guys hear me?
Yep, now we can hear you. Hello?
Not anymore.
Hello?
Let's try it again. It's just a
It
mute.
doesn't work. Sorry, I'm afraid it doesn't work.
But now we just heard you.
We can hear you. Can you ask your question? So maybe I do it. Are all of those annotated corpora that you're using for training gold standard?
Yes, for the most part, they are gold standard. So I mean, I showed a bunch of different models. Yeah, so for most of them, they are in fact gold standard in the sense that they were annotated by experts. The only one that's different is the corpus that I showed you, or the model for sentiment analysis, because sentiment analysis is just this with the Amazon reviews and the stars, and this, I don't know, could also be seen as gold annotated, but it's not like expert annotated. So everybody just wrote a sentence or like if they liked it or not, and then they gave 5 stars. But of course, the difference is that some people have like one, like, I don't know, write something very negative and then give 4 stars or something like this. And some people say, oh, it was good, but delivery was slow, and then they give 1 star. So it's not perfect data, but since there's so much of it, and it's generally pretty good data, it's pretty good data. Yeah.
Thanks for answering. David, what was your question?
Can you hear me?
Yes.
Okay. So imagine you want to get the similarity degree of kind of terms. A term could be 1 or more words. And the similarity degree could be similar, low similar, highly similar, or equal. Is there a way to achieve that with Flair?
Yes, I mean, so what Flair can give you is a word embedding for each word that you put in. There's many different embeddings. So we have, I don't even know, I think we have maybe 100 different types of embeddings that we have in Flair. So you could try out different variants of embeddings. And then if you have no supervision to train it, you could just use like a cosine similarity between the word embeddings.
And if I have, imagine I have a data set, I can train the embeddings with that, right?
Yes, yes.
Okay.
So
Perfect.
you can train the embeddings, and if you have like a data set of similarity, you could even train the similarity measure. But if you don't have a data set of similarity, you can just use cosine over the word embeddings, and that typically will work pretty well, I would say.
Okay, perfect. Thank you.
I think we're pretty much at the end, and it has been more time than we actually planned, I guess. And thanks for being so patient with us, and thanks again, audience. I mean, it was awesome again just to see the very cool questions you had, but you took the floor and did not hesitate to ask them. That's awesome. If Ellen, I would like to have you. Can you stay a few minutes longer? That would be nice. And so everyone, again, thanks for joining us this evening, and happy to welcome you again next week when we talk about not only racial bias, but about bias in general in machine learning models. I think also quite interesting topic given the bias effects, the side effects that has. And this is also cool stuff. Thanks, Alan, just for taking the time and being so patient and having that kind of very, very exciting speech. I see the feedback in the chat already. Very inspiring presentation. Looking forward to a follow-up. So see it as a kind of very positive feedback for what you've been doing.
Thank you very much, everybody, for listening, and thanks you for the many questions. I really like that. So thank you for inviting me.